Hey everybody, Mr. Grove here. Today we're going to talk a little bit about power. And so if work is equal to the force times the distance that the force is applied over, then power is going to be that amount of work that is done in a certain amount of time. And so it's the rate of doing work, basically. And so our unit is going to be the watt. In class, this is where I would make the joke, watt, and you would say watts, and I'd say watt. So kind of some science humor, but it's not as funny remotely. But watts are going to be our unit of power. And we're familiar with that, like light bulbs and things. But sometimes we need a bigger unit than just the watt, and so kilowatts would be that. So 1,000 watts would be a kilowatt. And then commonly for like engines and pumps and things, we would use horsepower. And so horsepower, 1 horsepower is equal to 746 watts. Okay, so let's work just a couple of simple examples, and hopefully that will help kind of give you a base for your problems. So the first one, we had an electric pump, 10 horsepower, and we want to know how many kilograms can it lift straight up at a constant speed over a time period of 35 seconds. So how many joules of work are done, and then what would be the amount of kilograms that we can lift. So we're going to start off with our power equals work over time. And so we'll set that up. So we know the power was 10 horsepower. And if we convert that into watts, so that would be 7,460 watts. Okay, and then that's going to equal the force. So our force, in this case, will be the weight that we're lifting, times the distance. So our distance was 30 meters over a time of 35 seconds. So if we solve for our force weight, and this is what we're lifting, we would get 8,703 newtons. And then that's equal to mass times gravity. So if we solve for mass, we get 888.1 kilograms. Okay, so that's our first answer. Then how many joules of work would be done? So for that, we just take our force times our distance. So our force was 8703 newtons times our distance of 30 meters. And that's going to equal the work. And so for that, we would get 261,099 joules. Okay, so that would be how we do that example there. Okay, and you may round a little differently, and that would be okay. Let's try another example. So in this one, we got a force of 1,500 newtons propelling a car at 15 meters per second. So let's take a look at our power equation. So power equals force times distance, and that's over time. Okay, well, distance over time is kind of like velocity, so that's distance over time. So we can take our 1,500 newtons times our 15 meters per 1 second, and that would give us our power. So that's going to come out in watts. So we would get 22,500 watts after crunching some numbers there. And then when we convert that, knowing 1 horsepower is 746 watts, that would turn out to be about 30.2 horsepower. Okay, so a little different flavor on the same equation, just looking at this as more of a velocity times force rather than work over time, but it's still the same concept. One last one, and so this is, we're pushing a crate up a ramp, 5-degree ramp at a constant speed for 80 meters over a time of 800 seconds. So we want to know what's the work that we need to do to do all this, and then what would be the power to do it in the 800 seconds. So first things first, we'll need to do our little force equation. So I had positive and negative, so push minus friction minus force weight X. And then on the vertical components, we had normal minus force weight Y. So in working on our triangle for our force weight, we can break force weight, 980 newtons, into force weight X by taking 980 times the sine of 5 degrees, and then force weight Y would be cosine 5 times 980. Once we get that, we know our force normal is basically going to be this 976.3. Okay, and now we can put this over here on our push. So our push is going to equal our friction, which is normal. So 976.3 times our mu value of 0.22 was given to us, minus our force weight X, which in this case would be 85.4. And that's going to equal MA, or 0. Well, we are at a constant speed, so that would be 0. So when we solve for push, we would come up with 300.2 newtons. And then to get our work, so that would be our force times our distance, so it's got to be in the same parallel line. So we're pushing it up the incline, and our distance is up on the incline. So that 300.2 newtons times our 80 meters would give us our work. And so that's going to give us 24,015 joules. Okay, and then taking our work over our time, so if we take that divided by the 800 seconds, that would give us our power, which is going to be $30 watts. So that would be our answer. Okay, so those are 3 power-related problems, and I hope that was helpful.